So I'm really delighted to be here. Thanks for making this happen. All right, so one question that might pop up. Why am I going to be presenting about generative AI, taking my background into consideration? Because my background is data engineering. Well, you could see that Datamole is a company that focuses on AI solutions. And since I've been cooperating closely with Datamole for past 8 years, I thought it's about time for me to actually wrap my head around what the AI is. So bear with me. This is really going to be about my journey on entering the realm of AI. And I think it's about time, right? Because if you take a look at the articles, if you take a look at the hype, everybody's talking about AWS. Sorry, let me find my notes. Everybody's talking about AWS. In 2025, Amazon invested more than $100 billion into their AI solutions. They were building their own silicon platforms, Trainium 3, Graviton 5, new processors, tailor-made for AI. If you had a chance to attend reInvent, you might have noticed that like 90% of the presentations are about AI. So that's pretty determining. Also, besides for the hype, besides for the practical application, there seems to be now a lot of theoretical background. What I really like is that AWS introduced the well-architected lenses for AI, ML, and generative AI. So that's also very encouraging. But even globally, like EU AI Act is now effective since 2025, which means that the credibility of the AI is increasing. At the same time, however, there are still some signs that this might be a bubble, right? Not everybody is super enthusiastic about AI, and I have to admit that I was among those who were a bit reluctant to go all in, because even the white papers that are now available are saying that the productivity increases by roughly 3%. For engineers that rely on generative AI, the numbers were even worse back then. The return of investment for many companies is not meeting the expectations. So it's not really just all shiny. Nonetheless, I am on the same page with that handsome guy. That's not me, that's Jeff Bezos. You might have heard about him. Who believes that while this indeed is an industrial bubble, it's not to be compared with financial bubbles. Yeah, so eventually this might pop and there might be a disillusion, but there will something tangible remain afterwards. Yeah, because I think we all know that already all the money that were invested contributed to something tangible that is helping us on daily basis. So I think even in the worst case scenario, this is still something we should pay attention to. Maybe I'll do a quick detour for those who are interested in how bad this could become. I would suggest everybody to look at this AI 2027 blog post that was created by OpenAI engineers that basically depicts the dystopic future we might live in if we do not manage to keep the AI under control. It's pretty nice read. All right, let me go back to the presentation. Sorry, I'll be switching over between the IDE browser and presentation, so it'll be a bit messy, but bear with me. Okay, so at certain point, even I decided that it's a good moment to understand what's actually happening under the hood and to stop complaining about AI being too non-deterministic, obscure, unreadable, hard to reason about. That's where the journey starts today. And I would like you to join me on the journey towards building a minimalistic chatbot, agentic chatbot on top of Amazon Bedrock and Bedrock Agent Core that will give you hopefully some insight into how things work internally. All right. when I started thinking about how to approach the AI in general, it turned out that it's a pretty big topic. As you might have noticed, there's reactive AI that's beating us in chess. There are discriminative AI that's good at categorization, narrow AI, which is something that Datamole, by the way, is that's where Datamole started. AI really focused on concrete tasks for concrete domains. But then there is the generative AI, right? So everybody's now talking about it. I think we cannot ignore it. And that's where I really wanted to understand how the guts look like. But even then, when I looked at AWS, what does it offer in that regard? It turned out that the amount of services they offer is vast. It's not just the tooling that allows you to build the AI. They also offer a lot of ready applications such as Amazon Q that are really tailor-made for specific problems that you might face. Sanjay will be talking about Cairo, again, a nice application of the AI in practice. But on the other side of the spectrum, if you really would like to go deep, AWS offers the hardware that you might help you build your own models. It offers SageMaker and other tools that really allow you to go really deep. But what I was looking for was the sweet spot somewhere in between. And eventually it boils down to two options. So if you would like to start building agentic chatbot in AWS, you would end up using either AWS Bedrock or AWS SageMaker AI. Which one to use? I'm not the first one who raised this question, for which reason, again, AWS came with very nice documentation that should clarify upon the challenges you might encounter along the road. So if you're interested in the details regarding how do these services compare to each other, then this is the document to go through. Nonetheless, I'll keep it really lightweight and will give you an executive summary. So basically, if you have a complex problem, you have a deep insight into AI, you have a skilled team of data scientists, then AWS SageMaker AI might be a tool of choice. If you have 3 days to prepare a presentation for AWS User Group meetup, Bedrock is your best friend. Yeah, so it should really shield you from quite a lot of challenges you might face. It's really to help you use the AI in practice, generative AI in practice. Good. Before we delve into examples and some hands-on demos that will likely fail because of the demo effect, I think it's essential to clarify upon two fundamental concepts that we will be dealing with. I think it's really important to understand the difference between the foundational models and agentic AI. So what is foundational model? Foundational model is a neural network that has been trained to yield an output for a specific input, and that's it. There is no state, it has no memory, it's not capable of interacting with external services, it doesn't have any additional context. It's stateless component that basically answers your demand by providing you an output. On the other hand, we have AI agents that are systems that utilize the foundational models to meet goals they are tasked with by the users. They are autonomous, they could retain state, they have memory, they are able to reach out for an external information through tools. So they're autonomous in what they're doing. And this is where I would like to start a discussion. So as I said, for the exploratory exercise that I went through, I decided to use Amazon Bedrock, which offers a variety of features. Here on the slide, you could see that it's the foundational models. It allows you to declaratively build agents, but besides for that, it also allows you to evaluate different foundational models. It allows you to fine-tune the models, wire knowledge bases, also handle data protection governance, At the same time, however, since we're restricted in time during this presentation, I'll be focusing solely on the foundational models and the agents as like a critical path towards building a autonomous agentic chatbot. All right, let's get our hands dirty. Now is the part where things will cease to work. So let me log into AWS. This is Amazon Bedrock console. So this is the experience you'd face if you'd actually start working with Amazon Bedrock's through console. And let me start by showcasing the model catalog. Yeah, this is typically where the story starts. If you'd like to build a generative agent, you need to choose your weapon. You need to choose the foundational model. And the catalog you could see is a nice entry point for you to come up with the decision. At the moment, there are more than 200 models available. So for instance, you could see that there are some available from Amazon, from their Nova and Titan families. Nova 2 Lite being one of the models introduced recently during the latest reInvent. So if you'd go into the detail, you could see what it's capable of, how you could reference it, what modalities is it capable of handling, etc., etc. So this is a very nice read for those who are interested in choosing which model fits their need the best. Nonetheless, what is very nice is that besides for the catalog, inside Bedrock, you also have this interactive playground, which allows you to select a model you would like to evaluate. So let's go with Nova 2 Lite. Am I presenting? I'm presenting. You apply. You just need to provide a very basic configuration. For sake of this demo, I came up with a system prompt that instructs the foundational model to act as an AWS superfan. You could tune it according to your needs, but you could see that it's rather easy. It's purely declarative configuration. And once you're done, you could evaluate the model's functionality by testing it online. So for example, where can I go for a dinner in Brno? And if you run it, our AWS enthusiast will hopefully give us some hints about the Brno AWS region. So this seemed to work. What is very nice about this interactive playground is that it also has the compare mode. So you could put second model alongside the first one and really see them both in action. So this time we could choose Gemma from Google. We'll provide it with the same system prompt, and we will trigger the same prompt. We will provide it with the same prompt. And now we could see that there are two outputs from two foundational models, and it gives you a hint about which behaves better against the requirements that you might have. What is important to keep in mind is that these foundational models are Amazon first-class citizens. Each of the foundational model have its own ARN. It's an AWS resource that you could interact with through the APIs and SDKs that AWS offers. So if you are building a solution where you do not need to retain state, where you do not need to have a memory, where you do not need the model to interact with the outer world, you could do with just the foundational models. And for that, I could showcase it in my Jupyter notebook. So this is another moment where things could go haywire. You could see that you might use Boto3, for example, as a wrapper towards an Amazon SDK to invoke the model by providing its identifier. And if you do, prompt it, for example, with a question, who is the President of the United States as of February 5, a request would be issued against the model, and you would be provided with the answer, which is a bit of a surprising one, right? Because it says that the president is Donald J. Trump, which sounds about right. At the same time, however, you could see that it assumed on Trump being the president based on the information it has from 2023. I think. Not certain. Yeah, but in the end, this really demonstrates that the neural network has been trained at a certain point in time, and all it could do is to answer your prompt based on the information that it has baked in, that it was taught on. All right, so this is about calling the models directly through an SDK, through an API, but it's also worthwhile noting that there are models with different modalities. So it's not just text that it could generate. If we were not striving for building a chatbot, if we were, for example, interested in building an application that would provide you with an images, then we could use a different model, for example, Nova Canvas, and invoke it again through the Boto tree or AWS CLI or API directly, and it would be returning the response in the modality that you selected. So this time we will be providing it with a textual prompt, minimalist self-portrait with a modern, clean aesthetic, and this should give us an image of how the canvas model look like. Let's see. Interesting. All right, so that worked out. So it's a pretty neat shortcut that you could take in order to wire in AI or generative AI into your application without having to build any heavyweight agents. At the same time, however, that is still the gap, right? So if you need the memory, if you need its contextual awareness, if you need your agents to behave autonomously, you need to cross the gap from the foundational model towards the agentic AI. And even in Bedrock, there is the possibility. So here in the menu, you could see it offers a agent solution. I left it here. So let me go through the demo again together with you to showcase how easy is it to set up an agent. So you could see you just start by creating an agent, you give it a name. As you've already seen, this time I'm putting the bar a little higher. I would like my agent to act as a god. I've once again readied a simple prompt that might instruct him to do so. So if we would go through the builder that Bedrock offers, we would just give it a name. We would just specify a role that is going to be used for interacting with the underlying model. We would select the model. It's noteworthy that only some of the models are Bedrock agents optimized. So for example, here you could see that we need to go with the older version of the Nova Lite 1.0, while 2.0 is already available, but so be it. We will give it the system prompts. You are a god with absolute power and far too much experience. We could set up various things, but for sake of this demo, let me just enable the memory to showcase that it's now capable, unlike with the foundational model, to retain the memory. And we will go with defaults for all the other options that we have. And if we save and exit, we prepare. That's an additional step that needs to be made. And now we have the agent ready. Yeah, so again, here, even in the console, we could test it right away. So if we would go hi, it should reply, greeting mortal. Yeah, so it sounds like God did descend from heavens to greet me. But now we could also showcase that besides for this basic capability, it should be able to, for example, retain information about my name. So if I'd say my name is Thomas. Come on. It greets me back, and if I ask it, what's my name? This time the memory should kick in, and it knows that my name is Thomas because it persisted the state in the memory. This was the trickiest part of the demo because it doesn't really behave deterministically. You know, like one time it might give you the information you're looking for. The other time it might be complaining about not sharing personal information or stuff like that, for which reason it's really handy that you could see the actual trace of what has happened under the hood. And that's where we're entering the dark magic. Yeah, because you could see that besides for the system prompt that I initiated the agent with, there is a lot of boilerplate that has been added by the underlying agent framework that Amazon Bedrock relies upon. And for a normal user, this is really hard to decode. Yeah, so this is the price you pay for the Amazon Bedrock agents being a declarative framework. Yeah, so you really just configure it, it works, but a lot of magic is happening under the hood, which brings us to the alternative, being the agent core. What is agent core? Amazon Bedrock Agent Core is a modular set of capabilities to build, deploy, and operate production-grade agents securely and scalably using any framework and model. All right, let me switch over to presentation. So in summary, like Bedrock agents, very simple, declarative. You could create it in a couple of clicks. It takes 10 seconds. It's done. You don't have, on the other hand, the control you might want to have. If you'd like to build solutions that you have a full control over, if you plan on productionalizing and really being in charge of what's happening, then probably you should aim for using Bedrock Agent Core. All right. Just like with Bedrock, Agent Core is not just one thing. It's a set of features that you might utilize in order to build your agents. It does offer memory as a service. It gives you a possibility to connect your agents towards external systems through gateways. It does offer a couple of handy tools that you might use without having to implement them yourself, such as browser tool or code interpreter. Important part of the agent core offering is the runtime, which is like the hosting environment to which you deploy your agents. But it's also a tool that allows you to deal with the identity, authentication, authorization relevant challenges on your behalf without having to re-implement everything from scratch. And of course, it gives you the observability, which is a fundamental part of every production deployment. So before we delve into the actual implementation of a simple chatbot on top of Agent Core, let me clarify upon the anatomy of the application. So in the core of, in the heart, it might be better to use the mouse, right? Is it visible? Yes. So in the core of the solution, you would find the agent framework. It's a component responsible for making sure that whenever user issues a prompt against the agent, it utilizes the tools and foundational models it has available in order to meet the goals that it needs to reach. For sake of the demo, I decided to rely on LangChain, but I'll be also clarifying upon the fact that thanks to the agent core, you could use any agent framework you'd like. So in context of AWS, that might be, for example, Strands. There's native agent framework, but Google Agent Development Kit works, OpenAI Agents SDK works, Crew AI works. So whatever fits your purpose could be used. Once you've decided upon the agent framework to orchestrate the actions needed in order to reach the desired outcome, you need to connect it to a memory, which is again a feature offered by Amazon Bedrock Agent Core. And you need to select a foundational model that will fuel or act as an engine of the logic that is to be implemented. Once you've done that, you could containerize it, create a Docker container, and have it deployed into the Agent Core runtime, which then deals with the typical challenges you might face, such as scaling, reliability, resiliency, all the things that you would expect from a production-ready workloads without you having to be responsible for it to happen. Going one step deeper, for sake of the demo, I decided to rely on Python, and these are the libraries that I had to use in order to put things together. So as already stated, as an agent framework, I decided to use LangChain. I'm no expert at all, so if you're having in-depth questions about this particular piece of the demo, then I would probably point you towards Sanjay, who said that he has some nice hands-on experience, even though I guess quite a lot of people in the audience already has it as well. Once we've decided upon the agent framework, it's important to facilitate or allow it to make use of the foundational models offered by the Amazon Bedrock. For that, I relied on LangChain, AWS Python library module that integrates the agent framework with Amazon Bedrock. We need also an adapter for the memory. There I relied on the LangGraph Checkpoint AWS module library that basically allows the LangChain agent to make use of the agent core memory service. And lastly, you need to integrate the implementation of the agent with the runtime, agent core runtime, for which the Bedrock agent core library is to be used. All right, demo time. So I'll be going back to my IDE. So I'll open the actual implementation of the agent. For a starter, you could see it's 90 lines long, including comments. So that means it's a rather simple thing. But let me guide you through the individual components that make up the agent. So first of all, we need to instantiate an adapter that allows LangChain agent to interact with the Bedrock models. Second, we instantiate an adapter that allows LangChain agent to interact with the agent core memory. There are two such adapters, one for short-term memory, the second one for the long-term memory. And for sake of this demo, I've also added one more extra, being a simple tool that we could give to the LangChain agent in order to be able to interact with the outer world. In a real-world setup, we would probably strive for a bit more complex solution, relying on MCP and agent core gateway, but this is really to demonstrate that if you are constrained in whatever, there are also shortcuts that you could take. Once we have these, we just instruct the LangChain library to compose the agent for us. We just specify the model to be used, the short-term memory adapter to be used, the long-term memory adapter to be used, and the set of tools that the agent will have an access to. Once we have the agent available, we could proceed to the next line, where we are instantiating an adapter that will allow us to integrate our agent with agent core runtime, declaring the entry point. This is probably similar to what you might have experienced if you've ever written a Lambda function. Again, there is a handler that is invoked by the user request anytime the agent is invoked. It might contain some payload originating from the user. It might contain some contextual information. And if we go into the body of this method, you could see that we extract the information about the actor, information about the session, and the actual prompt that the user composed, and feed it to the agent that we've instantiated earlier. The output of the agent is then returned, and that's pretty much it. Yeah, so it's that simple. Obviously, a lot is happening under the hood, but I really wanted to showcase that it doesn't have to be complex. Furthermore, to to stress the distinction between agent core and Bedrock agents. This is a Python code. And you could treat it as such. You could test it, you could run it locally. Again, let me go into my Jupyter notebook. So here is an example where you could see that I just import the agent into my notebook, and I could just run it directly from my local station because I've enabled the debug mode on the agent. It even gives me information about its reasoning. And if we're lucky enough, eventually it will be able to yield the desired information. Demo effect. Oh, here we go. Yeah, you could see that probably got stuck in the tool usage. It was searching the web to answer my question, who the current president is. And this time you could see that it's pretty confident because it found the information on the web. All right, so now we have the agent. If I would follow the recipe that I presented in my PowerPoint presentation, the next step is to compose a Docker file that would allow me to translate it into a Docker image. Again, I went with a very minimalistic Docker file just to showcase it works. And once we have the Docker image, what remains is to instantiate the agent core memory resource and deploy the Docker image into the agent core runtime such that all the pieces fit together. We could obviously do that through console, but since I really wanted to showcase something that has a potential of eventually being promotable to something productional, I implemented these steps in Cloud Development Kit. I guess everybody here is familiar with Cloud Development Kit. It's infrastructure as code framework that translates Python code into CloudFormation templates. So if we would go into respective stack, here you could see that it aims to deploy a Bedrock agent core runtime. It's backing memory store and custom agent image hosted in Amazon ECR. Here are the individual steps. So in the first step, we instruct CDK to create the agent core memory for us. We specify some strategies on how the long-term memory is to be treated. We instruct CDK to build the Docker image on our behalf, have it persisted in ECR, and then we would instruct the CDK to create the runtime based on the image that is referenced. Besides for that, we need to provide the agent with the parameterization, being the identifier of the memory that it needs to use, the ID of the model. And last but not least, of course, we also need to make sure that the policies of respective roles are configured correctly. This is the part of the demo that I didn't have balls to showcase live. So I did run the CDK deploy command before the demo. But you gotta believe me, you gotta trust me that it would eventually end up deploying the entire infrastructure into AWS. So again, if I would go into browser, into the agent core console, Amazon Bedrock, agent core. Okay. Now you could see that we have a memory created. You could see that we have a runtime created. If we open it, the console gives you info about the agent that we've deployed. But besides for other things, it also exposes the endpoint that might eventually be invoked to yield the output of the logic that we've implemented. It's convenient that you could test it from within the console. So once again, I could greet my minimalist agent. And if I hit run, with a bit of luck, the runtime will process the incoming request, will run it through the LangChain agent, yielding the result being the response. Once again, it's important that this runtime alongside with our agent is first-class AWS citizen. So again, you could use CLI, SDK, Amazon APIs to invoke the agent runtime and yield its outputs through any means that you see fit. So if I would here trigger my custom agent through Boto3, then again, I would expect that in a couple of seconds, we'll be provided with the information originating from the guts of our custom agent. All right, that's pretty much it. What I guess remains to be shared, and that's the part that we don't like, but it's important, as the pricing. So first of all, regarding the Bedrock agents, the first declarative option that I showed, it's charged based on the foundational model inference. So basically, the amount of tokens that you process by the agent. The prices are pretty nice, I would say, for prototyping and for testing. It's practically free. Nonetheless, as we all know, that's where the trap is with AWS, that once you scale, it might become very expensive. But at least for the introductory purposes, it is almost free. What is interesting is that the Bedrock agent doesn't charge you for the memory usage because it's not part of the services or features that it exposes. With Agent Core, on top of the price for the inference of the foundational models, you pay for the Agent Core runtime, which is usage-based. So basically, the amount of CPU and memory you consume during a session, build per second I/O is not charged. So again, if used wisely, this is actually really cheap. This is actually really cheap. If you'd compare it to, say, a workload that you'd be hosting in an EKS cluster or ECS cluster or something like that, this is incomparably cheaper. Memory pricing, short-term memory, 25 cents, 1,000 new events, 75 cents per 1,000 records stored, $0.50 for 1,000 events retrieves. All right, so these are the topics that we might delve into during some of the coming sessions, or it's for you to think about the next steps you might take. So first of all, obviously, you would like your agents to be integrated with the knowledge bases. You would like your agents to be aware of the contextual domain-specific information. It's good to have a dedicated session about tools, basically the agent's capability to interact with the outer world. It's a rather complex topic, in the end, closely related to the emerging MCP protocol that is now being used everywhere. Address the authentication authorization issues. This is related to connection to the outer world. And designing the agent-to-agent interaction patterns beyond single-step flow. So what I showcase is a simple one agent, but in the end, you might want to have swarms of agents that are cooperating in order to meet its goals. But it's, again, yet another topic that we will not be delving into today. And finally is the observability. I didn't touch upon the topic, but both Amazon Bedrock and Agent Core give pretty extensive capabilities in that regard, allows you to reason deeply about the workloads you have hosted in them. And that's it from my side. Thank you very much for your attention. It's worthwhile noting that Datamole is hiring. So if you'd be interested in data engineering challenges, if you're thinking about moving to a new position, then we'll be delighted to have you on board. We're looking for AWS enthusiasts, so I think there is no better space to ask for the talents than here. So thank you very much. This is from my side, and I hope you enjoyed the presentation. Thanks. Yeah, I think it might be also worthwhile to ask whether there are any questions. Please.
Hello, I would like to ask about what are the main competitors, or let's say alternatives to Amazon Bedrocks. I think that Microsoft or Google can also provide those similar services.
Yeah, that is my expectation. I forgot to mention that AWS Bedrock is really established service in AWS. I think it's since 2023. So it's not like that this is something new, that this is something, bleeding edge. And all the other competitors are at a similar pace. Nonetheless, it's hard for me to reason about the competitors because AWS is AWS. That's the cloud of choice. Sorry, I don't know. I know that there has been some tests in Azure in the Prague part of Datamole, but unfortunately, I was not involved in the initiative, so I can't reason about it. But thanks for the question. All right. I could see I left you speechless. And all right, one more question. Go ahead.
Thank you. Deployment agent by the Docker, but we had issues with the Docker that it started like 20 seconds and like deploying the agent directly, for example, with code in Python, it was much faster. Do you have some experience with this?
Yeah, honestly said, for me, this was an exploratory journey. So none of the artifacts that I presented actually made it into production. So it could be that once we have that desire, we would start hitting walls here and there. But I know that even AWS gives a couple. This is something that I did not mention again because we would be going into too much detail, but if I'm not mistaken, they have several tiers, each of which goes with different guarantees. So what I showcase is like the standard tier where, for example, the startups times and stuff like that are not guaranteed. But if you're willing to pay a little extra, you could then rely on higher tiers, which might provide better performance.
Yeah, okay. Like premium is always the choice in the cloud. For the hyperscalers. Anyway, could I ask your AWS colleague what AWS recommend for deploying the agents, code or containers?
Well, I mean, honestly, I think it depends. Would be my fair answer, but I think you have some specific issues that you're facing. So probably after this, we can take it offline. We can understand what really you're facing, and I think you're probably not the only person, and there should be a path to green there. So yeah, let's speak about this later. Yeah.